very good afternoon. Myself Dr. Ruchi Gupta, Associate Professor IT Department. Today we will discuss software engineering concept and the comparison of software engineering with some other engineering concepts. So, first of all, what is software engineering concept? Software engineering, it is basically a combination of two words. One is software and another one is engineering. So it is a combination of two words. One is engineering and second one is a software. So what is engineering? Engineering is basically an application of science to that provide the solution of the various problems in any of the field. So we can apply engineering in any of the field, but when we have to combine it with the software, so we can say that software engineering is a systematic approach for solving any problem, or in terms of the software, how we can develop the software. So it is a systematic approach for the development of any software. So the field of software engineering was born in NATO conferences in 1968 in response to chronic failure of large software projects to meet schedule and budget constraint. So before the 1968, software was also implemented, but due to lack of systematic approach, maximum softwares were destroyed due to some schedule problem, due to some budget problem. So that time major projects were destroyed. So now there is a need of some engineering approach. So that approach was involved in 1968. Since the term became popular, software is getting more and more important in industry and business, but the software crisis still persists. So as we have seen in the today's environment, softwares play a very critical role, very important role in any of the field. So it become a popular day by day. But still there is a problem of software crisis. We have faces the software crisis problem also in today's environment. Now we come on the actual definition of software engineering. So as per the IEEE standard, as per the IEEE, the definition of software engineering is that the application of a systematic, disciplined, quantifiable approach to the development, operation and maintenance of the software. So we can say that it is a systematic or disciplined approach. It is a quantifiable approach for the development, analysis, design, development, testing and maintenance of any software. So that is the application, that is the application of engineering to the software. So another definition of software engineering, it is concerned with theories, methods, tools for the developing of software or for managing and evaluation of the software products, and this definition is to be taken by the Somerville. Another definition which is to be taken by the Stephen, a disciplined approach whose aim is the production of a quality software that is delivered on time, on budget, and it also satisfied all the customers' need, which are the expectation of the customer. So another definition is a multi-purpose construction of multi-version software that is taken by the Parnas. This is another definition, the practical application of scientific knowledge in the design and construction of programs and some associated documentation that is required to develop, operate and maintain the software, and this definition is to be taken by the V.W. Boehm. Another definition of software engineering is that this is the establishment and use of sound engineering principles in order to obtain some economical software that is reliable and work efficient in the real machines or for the real environment. This definition is to be taken by the F.L. Wurr. So overall, we have read about many definitions of software engineering, but the overall gist of this definition is the only one, is that we have applied a systematic approach for the designing, development of any software, and ultimately we have to deliver a quality software to the customer. That quality in terms of means if the customer is to be delivered on time, on budget, or it will meet all the specified requirements of the customer, that we can say that it is a quality software. So software engineering is basically a process to deliver the software with all specified requirements of the customer. So this is another definition of the software engineering: the technological and managerial discipline concerned with the systematic production and maintenance of the software product that are developed and modified on time within the cost constant. So as I have seen the many definitions of software engineering, we have seen that the concept, the objective of the definition, it will remain same. So this definition is to be taken by fairly. Now we come on the another definition. This is a disciplined approach that deals with the building of the software system, which are so large and they are built by a team or a team of engineers. And this definition is to be taken by the AKGEC. So a software implementation is a teamwork. So we have to, any company have to create a team of developers. They have to create the team of analyzers, designers, testers, maintenance team also there. So we can say it is a teamwork. So in the team we have to develop any software. That's why it can be delivered on time and on budget. These are some other definitions of software engineering. So first of them is that a systematic approach to the analysis, design, implementation and maintenance of software. And this definition is to be taken by Online Dictionary of Computing. The another definition of software engineering is it is a systematic application of tools, techniques in the development of computer-based application, and it is to be taken by the CEO Conger. Another definition is software engineering is about designing and development of high quality softwares. It's also taken by Sri Levrinse, production of quality software. So as we have seen here that we have taken about the various definitions of software engineering, but the major objective of this definition, it will remain same, that software engineering is a systematic approach for the analyzing, designing, development and testing of any software. And the whole purpose of this concept, by using this concept, is that we want to deliver a software to the customer on time, on budget, with all specific requirement or with all expectations of the customer, so that we can say that we have to deliver a quality software to the customer. Now, software engineering, there are various goals of software engineering, and there is also certain scopes of software engineering is there. So the scope of software engineering is a study of software process development principle, techniques and notations. So we have used various process development. We have used certain models for the implementation of softwares. We have used principles of software engineering, as well as we have to use various techniques and notations which are used in the development of software. Now, the goal of the overall goal of software engineering is that we want to deliver a quality software. We always deliver the quality software in terms of time, in terms of budget, and it satisfies the customer requirement. So these are the major goals of software engineering. The production of a quality software, we have to implement a quality software in terms of that delivered on time, it will delivered within budget, or it specify the customer requirements and user needs. So these are the goals of software engineering which we have to keep in mind when we have start for the implementation of any project. This is a layered approach. Software engineering is a layered approach, and they are basically, these are the 4 layers: quality focus, process, methods and tools. So, these are the 4 layers of software engineering. So, first of all, we have to use the tools through which we have to develop the software. Then we have to use certain methods through which we have to develop any software. We use various methods, and also we use a process. In the process we have to use various models which we have discussed later. And the whole purpose of the software engineering is to develop a quality software. So, our main focus is on the 4th layer of this software engineering, that is a quality focus. Now, this is a similar: tools, method, process and quality focus, and all are related or all are interlinked with each other. As we have seen in this figure, these layers are interlinked. All these layers are interlinked. Now, quality focus. What is quality focus? It's bedrock the support software engineering. The process, it is a foundation of engineering. Methods, it will provide a technical that how we can build a software. Means we can say that what models we have to choose for the implementation of software, and these models are to be choose as per the requirement of the customer. Now, the next one is the tool. Tool means that pre-automatic and some automatic tools. We use some automatic tools or some pre-automatic tools for the implementation of software. Now, we come on the differences. Difference between software programming and software engineering. So, as I have discussed various definitions of software engineering, that software engineering is a systematic approach for developing any large project. So, if any company wants to develop a large project, so in that case we will apply the concept of software engineering. But when we have to compare it with the software programming approach, so programming, it's a teeny, we can say it's a teeny application of, it's a one phase of software engineering. So, software programming, the definition of this software programming is that the process of translating a problem from the physical environment to the language. If we are comfortable in any of the language, or if we know any technical language, then the programming is only just the conversion or the translation of the simple transmission of the physical environment to the language. So, this is the definition of programming: the process of translating a problem from its physical environment to understand the computer, that are understandable by the computer, because we know that computer only understands some language, that binary language. So, we have to convert it into the language. It is, if we are talking about the programming, only single developer is applicable, only single developer is create the program. That user is only responsible for the testing of program, because these are the toy applications. We are having a very short application. We are having, if we are implement a 100 lines of code or 1000 lines of code, then we can easily implement it can be easily developed by a single developer. So, we can say it's a tiny application or a toy application. It's a very short lifespan. Only single developer or only few stakeholders can involve in the program implementation, like architect, developer, manager, tester, customer or user. It is built from the scratch. We have to start from the scratch and we can implement it, and there is a minimal maintenance is required for the implementation of program. So, but we have to compare it with the software engineering. So, as I have already discussed that with the help of software engineering, we have to develop a large software. So, in the software engineering, it is a team of developer that play a they have to play a multiple roles. For example, there is a one team of analyzer, they only analyze the software. Another team of designer, they have to analyze the software and then designing the structure of the software. Then the third team is a team of developer, they have to code the whole software or a project. And the next team of tester, they have completely test the software. And the final team of maintenance team, they have to continuously monitor and upgrade the software as per the requirement of the customer or as per the technology change. It is very complex as we have to compare it with the programming, and the number of stakeholders are involved in this process, like architecture, developer, manager, tester, customer and user, and they all are different users. As compared to the program, all the users may same. When we have to develop a program, so there is a possibility that all the users play a single developer role. But in the case of software engineering, all the users are different users. Now, it is a system family and we can reuse it. And as I have already discussed in my previous lecture, the maintenance cost of the development and the maintenance, the cost of maintenance is 60% and the 40% cost is involved in the development part. So, we can say the maximum cost of the software is involved in a single phase of SDLC, that is maintenance phase. Now, if we are talking about the difference between the software engineering and system engineering, so system engineering, it is a broad term of software engineering. So, in terms of that, a system engineering is a part of process that concern with the developing of software infrastructure, control, application and database in the system. Means it is, we can say it is a broad term of software engineering. System engineering, it concerned with all aspect of computer based system. It include hardware as well as software. Means system engineering, we can say it is a combination of hardware as well as software. So, software engineering, it just a part, it just a one part of system engineering. So, system engineers are involved in specification, architectural designing and the deployment of any software. So, as we have to compare it with the software engineering, system engineering, if we have to compare it with the software engineering or a computer programming, that software programming is a subset of software engineering, we can say, and software engineering is a subset of system engineering or vice versa. Now, what is the difference of software engineering and computer science? It is again a broad category, it is again a broad range of software development. So, computer science is concerned with the theory and fundamentals of any of the system. So, software engineering is concerned with the practically of development of any useful software. So, in the computer science, we have to learn about the theoretical concept of softwares, and software engineering, we have to learn about the practical approach of any software. So, computer science theories, and still if we discuss about the computer science theories, they are still inefficient to act as a complete underpinning of software engineering, unlike the physical and electrical engineering. So, there is a need of software engineering. So, with the help of software engineering, we can prove it that the software is in correct form or not. Now, we come on the difference between software engineering and traditional engineering. So, software engineering, it is based on the computer science, because computer science will give us a theoretical concept of development of software, and with the help of software engineering, we have to implement that software, practically implement that software. So, information software engineering is based on computer science, information science and discrete mathematics, whereas the traditional engineering is based upon the mathematics, science and empirical knowledge. So, if we have to solve any problem with the help of traditional engineering, so we have to apply any mathematical concept or some empirical knowledge about that subject, some rules, some formulas, and if we are talking about the software engineering, so with the help of software engineering, we have to implement practically. So, traditional engineers construct real artifacts. So, traditional engineers work on the real artifacts and software engineering work on some non-real artifacts, attributes. So, in traditional engineering, two main concerns for a product are the cost of production of reliability measured by the time to failure, whereas in a software engineering, two main concerns are one of the cost of the software development and the another one is the total number of errors which occurs in the number of lines of code. So, these are two concerns about the software engineering and both disciplines require maintaining in a different way. Now, difference between software engineering and traditional engineering again. Software engineers often apply new and some untested elements in software projects, while traditional software engineers apply known and tested principles. So, if we are talking about the software engineer, they have to apply some real artifacts, they have shown some tested principles. Software engineer emphasize project that will live for the years or decades. So, when we have develop any software, it will work, we can say it will work lifelong. There may be a chance that the performance of software may degrade, but it will never die. We can use the software any of the time. So, software engineer emphasize project that will live for the years or decades, whereas some traditional engineers solve long range problems that ensure for centuries. Now, these are some challenges of the software engineering. So, any software engineer, when they are ready to implement any software, so they have to kept in mind some points so that the software, final software may delivered, maybe it may be a quality software. So, we have to consider all these challenges before the implementation of any project. First is the functionality. Functionality is the capability to function that meets some specified requirement of the customer. So, we have consider all the functions that are used, that are as per the expectation of the customer. Now, the reliability, it is a capability to maintain a specified level of performance. Now, usability means the capability to understand, learn and how it will be used. Efficiency means a performance of software, how we can define the performance of software. So, in terms of amount, in terms of resources or in terms of time. Now, maintainability, the capability to be modified for the purpose of correctness improvements. We have to implement a software in a way that it is easy to maintain. We can easily modify. Now, portability, the capability to adapt it for a different specific environment. So, these are some challenges which we have considered when we have to develop any software. So, thank you very much.